Let's examine complex numbers in this lesson. So essentially we're looking at what are complex numbers and how do I simplify them. Complex numbers are defined as a plus bi or a minus bi. So you'll often hear it a plus or minus bi, where a is the real portion coming from the real number system, which includes natural, whole, integer, rational, real, irrational numbers. And this part is coming from your imaginary number system, like the square root of -1. Together, it makes up the complex number system. So you've got a real part, an imaginary part, and this cartoon over here illustrates it beautifully. So here's our real kid here with his imaginary girlfriend added together, and definitely a complex situation. Okay? We're going to learn how to do all sorts of operations with complex numbers, but first I want to just remind you of your imaginary numbers. Your most basic imaginary unit is known as I, of course, and we defined this earlier as the square root of -1. Okay, so that's the definition. We also talked about what I squared is, but I just want to remind you. So if you would square both sides of this, if I square I get I squared. If I square the square root of -1, I'm left with just the radicand. Therefore, I squared is equal to -1. These are two good facts to be able to just spout off as easy as you can add 2 plus 2 to get 4. We can do all kinds of operations with them. So first of all, we can add and subtract them. And the beautiful thing is this just kind of works like combining like terms. So when I look at this, the real part, 8 plus -3, is equal to 5. And then I have -3i plus -9i. Well, that's -12i. So I'm going to write this as 5 minus 12i. Just like if that were 5 minus 12x, I wouldn't be able to combine that. I can't combine this any further. This is in the correct form as well. We can subtract them as well. Now with subtraction, I typically rewrite this where I kind of think about distributing this minus sign to my second set of parentheses. So this would be plus 2 minus 7i, and now I just combine my like terms. So I have a 14 plus 2 would be 16, and then I have a positive 8i, minus 7i would be a positive 1i, or just plus i. So 16 plus I is simplified. The next one, I have 10 minus, I'm going to rewrite this. I'm going to distribute my minus sign, so I'm going to make it 10 minus 4 minus 63i, plus 3 minus 2i. So I'm just kind of getting rid of all of my parentheses. Now I'm going to combine the real parts. So 10 minus 4 would be 6, plus 3 is 9. And then I have negative 63i minus 2i would be negative 65i. So here is my complex number, part real and part from the imaginary number system. We can also multiply them, and the rules work very much the same as with binomials. So I would distribute 4i times 5 is 20i. Minus 4 times 3 would be 12, and I times I is I squared. Now I need to remind you, what did we just say I squared was equal to? Well, it's equal to -1. So that means I can replace this I squared because it's not simplified until everything is written in the form of a plus bi. No I squareds are allowed. So this is 12. And I'm replacing that I squared with -1. So what I really have is -12 times -1, which would be positive 12. So that's the real part. I'm going to write that first. I'm going to write the 20i second, and that would be plus 20i since it's positive. In our second one, this would be like a complex times a complex. You could think of it as a binomial times a binomial. So I'm going to begin by distributing my 2, which gives me 6 plus 12i. Now I will distribute my -11i, which would be minus 33i minus 66i squared. So I can do a couple of things here. I've got some like terms here in the middle, which would be 6 minus 21i minus, this would be 66 times -1, which would make this right here be a plus 66. So I have 6 plus 66 which is 72 minus 21i. We can divide, and this is where it gets a little tricky. How do I do 3 minus 2i divided by 4i? Well, I look for something to reduce, and it would have to be both this and this reduce, and that's not going to work. So remember that I is equal to the square root of negative 1. And we are not allowed to have square roots in the denominator, so we need to get rid of this. So how do I do that? Well, I multiply by a disguised form of 1. I don't want that I in the bottom, because it's the square root of negative 1, so I'm going to multiply I over I, which produces, in the bottom, 4i squared. In the top, I'm going to be distributing. I've got to take I times each of these, which would be 3i minus 2i squared. Now, I squared we know is negative 1, so this is the same as 3i, and here I would have negative 2 times negative 1, and in the bottom I'd have 4 times negative 1. So that's going to be plus 2 over negative 4, and now I'm going to clean this up. I'm going to get things in the right order, which would be the 2 first plus 3i divided by negative 4. Now the final thing is, remember, complex numbers are in the form of a plus or minus the bi. So I'm going to simplify this right here to make this negative 1/2, and then it would be the positive 3 divided by negative 4 would be minus 3/4 I. So this is very similar to that idea of rationalizing the denominator with radicals. Of course, we're going to make things just a little bit more challenging. So take a look at this quotient, 7 plus 5i divided by 1 minus 4i. What does this look a lot like? Well, I'm hoping maybe it resembles when we had things like 1 plus root 2 over 5 plus root 3. And it was not okay here to have this in the bottom. And how we got rid of it was multiplying by the conjugate, which was just switch the sign on the middle term. Multiply by 5 minus root 3 over 5 minus root 3. We're going to do something very similar here. We're going to multiply by something here known as your complex conjugate. Okay, a complex conjugate, well, what's a conjugate? It's just where it switches the middle sign, okay? So 1 minus 4i and 1 plus 4i would be complex conjugates, okay? So one's a minus, one's a plus, everything else about them is the same. So whenever you have this binomial down in the bottom, what you do, the trick is you multiply by its complex conjugate, which would be 1 plus 4i over 1 plus 4i. So what we have here is a binomial times a binomial. So let's handle the top. We multiply by 7 first, which gives 7 plus 28i. Then by 5i would be plus 5i plus 20i squared. Over denominator, distribute the 1 would be 1 plus 4i. Now distribute the negative 4i would be negative 4i minus 16i squared. If I went fast, pause and go back and take a look at that. Now let's clean it up. A couple of things I can do. Anywhere I have an I squared, that's the same as negative 1. Look for like terms. Okay, I see some like terms here. So cleaning up, I get, in the numerator, I would have 7 minus the 20, because it would be 20 times negative 1, and then 28 plus 5 would be plus 33i. Move this up to give myself some more space. In the denominator, I would have 1 plus 16, because 16 times negative 1 would be positive 16. And then these terms here drop out. So in the numerator, I have negative 13 plus 33i over 17. Why did I have to do all that? Well, notice I have no i's down in the denominator. This is, in a sense, rationalized. We can't have I or I squared in the denominator, and actually can't have I squared anywhere in the problem. Okay, time for you to practice.